Okay, so let's take a look at our first actual example with numbers. So first confirm that it's in linear form. So it's dy dx plus some function times y equals something. In this case, we lucked out. We got a very simplistic approach here. Now, this is an example that we could do with separable functions, but because we're trying to emphasize this new technique, I'm gonna go through that process with you here. So first task is, so it's in standard form, and then I want to identify the p function. So p of x. So p of x in this case is equal to -3. So then I want to find the integrating factor by calculating e to the -3 dx, which if I integrate -3, I just get 3x. So that's just e to the -3x. Okay. Next is to take that term, that integrating term, and I'm going to multiply that by each term in the original equation. So e to the -3x times dy dx minus e to the -3x times 3y equals e to the -3x times 0, which is a nice boring scenario. Yay! So on the right side, we just get 0, so that was nice and easy. On the left side, if we did this correctly, then we should be seeing an illustration of the product rule. So then this would be the integral of d dx of e to -3x times y and dx. And if you want to take a second and just convince yourself that that is correct. So if I do product rule on those two terms, am I going to get the original expression we started off with? And hopefully you're convinced that it works. So in this case, when I integrate something that I differentiate, I end up with the exact same thing. So e to -3xy equals, then the integral of 0 is, well, nothing there. So then we get c to represent that constant. And lastly is to try our best to solve for y. So if I divide by e to the -3x on both sides, I get c e to the -3x, which we can simplify, and so we get y equals e to the 3x, sorry, with the c out front. So we got c out front, e to the 3x. And there we go. Okay, so there's our equation. So now that we've solved it, did we have any restrictions? So is there anything that came up on this one, since we didn't have to divide? I'm going to go back up to the directions here. So give the largest interval the general solution is defined. So that's where I look back at when I tried to write it in linear form. Now it came to us in linear form, so I didn't pick up any restrictions at that case. So this one doesn't have any restrictions, and our solution is valid from -infinity up to infinity. So it's pretty much valid all over the place. And since we don't have any restrictions to have a conversation about, then we don't have to worry about any transient terms in the general solution. Okay, let's look at another example. So x times dy dx minus 4y equals x to the 6 e to the x. So this is not in standard form, so I'm going to have to put it in standard form, which means I'm going to have to divide every term by x. So if I do that, I get dy dx minus 4 over x times y equals x to the 6th e to the x divided by x. And so that actually simplifies down first a little bit. So dy dx minus 4xy equals x to the 5th e to the x, and there we go. Okay, so now it's in linear form, and so now I want to put some effort into finding our integrating factor. So that's looking at that term right there. So we got p of x equals negative 4 over x. So I want to evaluate the integral of e raised to the integral of negative 4 over x dx. So let's move some things around. Let's see. So let's bring e to the negative 4 out front there. So that's dx over x. And that's e to the negative 4 of ln of x. So there we go. Now that actually we can simplify a little bit better because e and ln have some nice interesting properties there. So let's bring negative 4 up as an exponent of the ln statement, specifically the x inside. So that's going to give me e to the ln of x to the negative 4. And so that gives me x to the negative 4. So that's 1 over x to the 4th would be our integrating factor. Now I feel like I should pause real quick and go, okay, keep in mind, when we get done with this process, we're going to have come back and have a conversation about domain restrictions. So already we get a sense that when we divided by x in the beginning, that means we can't have 0 in there. Maybe there'll be some other restrictions. So because we used ln of x at some point, then we've got another restriction on 0 there. So it's not just 0 itself, but we have to have positive values of x that we are allowed to solve for. So, okay, but we'll come back and have another clarifying conversation there. Okay, so let me run over here and let's see what we got so far. So we're going to multiply every term by that 1 over x to the 4th. So we got 1 over x to the 4th times dy dx minus 1 over x to the 4th times 4. Sorry, my x to the 4th is not as clear as I want it to be. X to the 4th times 4 over x times y equals 1 over x to the 4th times x to the 5th e to the x. So yeah, we're going back into when we had it in standard form. We're not going up to the original problem at this point. Okay, so let's do a little bit of clean up best we can. Let's see. So 1 over x to the 4th dy dx minus 4, and let's see, minus 4x to the 5th times y equals x e to the x on that side. Okay, and if we did this right, so this part right here, right, that should be an illustration of the product rule. So that should be the integral of d dx of 1 over x to the 4th times y and same thing on the other side. Alright, so x e to the x there. Okay, and again, because the left side was picked to be an application of the product rule, feel free to convince yourself that we are looking at that. But when we integrate the same thing that we differentiate, we're left with, let's see, 1 over x to the 4th y. And then this integral of x e to the x, that is an application of integration by parts. So if you remember how that process works, I'm going to have one side I'm going to differentiate, and the other side I'm going to integrate. So going this direction I'm going to differentiate, and going this direction I'm going to integrate. So that gives me a 1 there, and that's just e to the x. So that's x e to the x minus the integral of e to the x dx, which is just e to the x. So I get 1 over x to the 4th y equals x e to the x minus e to the x. And we technically have that constant sitting there. And let's see, we want to do our best to solve for y if we can. So that means I'm going to multiply all my terms by x to the 4th. So that's x to the 5th e to the x minus x to the 4th e to the x plus c x to the 4th. Okay, and then the very last thing we want to have a conversation about, we kind of briefly talked about this. Oh, my dogs are barking. Okay, so if you recall, at the beginning of the problem, we divided by x, which means we can't have 0 in the domain. And then we also, when we integrated, we had a ln of x. So we want to make sure that element also is solvable. So we can't have anything negative because of the restrictions on ln. So that means our solutions have to be something positive, something bigger than 0.